All right, looking at example 2, in a recent study, it was found that medical students work an average of 81.7 hours a week. Suppose the distribution of the number of hours worked per week is unknown. So again, we've got the distribution is unknown. And we have a standard deviation of 6.9 hours a week. All right, so describe the distribution of the sample mean if we sample 60 medical residents. Well, please note that we have got a sample size that's bigger than 30. So we would know that X bar is normally distributed because we've got that minimum sample size met. So X bar is normally distributed. Our mean of our distribution would be 81.7 hours, and the standard deviation of the distribution would be 6.9 hours divided by the square root of 60. You can also write that, if you would prefer, as X bar is normally distributed with mean 81.7, standard deviation 6.9 over root 60. Take your pick. Doesn't matter to me. All right. Then moving on to question B, what is the probability that a randomly selected resident, okay, so we are talking now about n equals 1, all right, by this we will not be able to know, okay, so unknown. By the central limit theorem, if the distribution is unknown, we need n to be greater than or equal to 30, okay, to guarantee a normal distribution of sample means. So I'm just going to say if X bar is normally distributed. Okay, so in this case, we can't say anything. We just can't do that one. There are other means, but they are not means we will discuss in this class at all. So moving on to part C, what is the probability a mean number of hours worked by a sample of 35 residents is less than 80 hours a week? So we can do this one because we do have n greater than or equal to 30. Okay, so we can find the probability that the average number of hours worked is less than 80. So again, we will know that our means are normally distributed because we have n greater than or equal to 30. We're looking at less than 80 hours, so our lower bound will be our negative 1 E99, upper boundary of 80, our mean of 81.7 hours, and our standard deviation 6.9 divided by the square root of 35, which is our sample size in this case. And that probability, plugging that into your calculator, should be 0.0725, or about 7.5%. Okay, moving on to D. The probability, the mean number of hours worked by a sample of 95 residents is less than 80 hours a week. So we want the probability that our mean is less than 80 hours a week. So our normal CDF, again, no lower bound, so we'll use negative 1 E99, upper bound 80, mean is 81.7, standard deviation 6.9 over the square root of, in this case, 95 residents. Probability 0.082. Okay. Kind of scary, is it not? The probability a group of 95 works less than 80 hours a week is only 0.0082. Anyway, what might you conclude if the mean number of hours worked by a random sample of 95 residents is less than 80 hours a week? Well, again, we would conclude that maybe an assumption about the population is incorrect. Okay, so assumption about the population is incorrect. So maybe the mean number of hours worked is not really 81.7. Okay, maybe we need to change that. All right, and then almost the last part in this question here. So considering that random sample of 95 residents, okay, 95 residents, what would the sample mean need to be if they wanted to work more than 90% of all medical residents? They want to work more than 90% of everybody else. So I'm going to go ahead and draw this curve, okay? If this group of 95 wants to work more than 90% of everybody else, they want to basically be up here in this top 10%. This 90% is what is down here. So this group is looking to be in this top tier, okay? What we want to figure out is what is X bar? What is the number of hours that's going to make that happen as an average for that group? So we want to figure out what X bar is, and so we need to know the inverse normal function. Now again, those of you without the prompts, you're going to put in from down here at the bottom, what is the area up to that point. So we're going to do 90%, mean 81.7, standard deviation 6.9 over root 95. We've got a sample of 95. For those of you with the prompts, you can do this one, and that would be to the left. You can also do 10% as your area and use the right tail. It's up to you, okay? Regardless of the method you choose, you should end up with 82.6 hours. So if they want to be in that top 10% of people working a whole lot, that average would need to be more than 82.6 hours. So we're going to go ahead and write that then as an interpretation. So if a group of 95 residents work an average of 82.6 hours every week, then they are working more than 90% of all such groups of residents. Okay, if a group of 95 residents work an average of 82.6 hours a week, that group of 95 is working more than 90% of all such groups of 95 residents, if you will. Okay, again, comparing apples to apples, groups of 95 to other groups of 95. All right, if you would like to tackle example 3 on your own before watching the next video, that would be great. Use it as a way to double check and see if you're starting to understand the concepts in this section.